When I first made my Ford compiler public, I just couldn't release it without an editor. And I did, albeit a port from the classic VIC Ford line editor. But still, I felt something was missing. You have to know that 40H was developed using Borland Turbo C version 2. And that one came with an example spreadsheet, which was unbelievably cool. I mean, we had Lotus 123 at the time and you had to fork out about $500 for the privilege to use it. Of course, Borland's spreadsheet wasn't as capable as Lotus 123, but for us mortals it was good enough. So 40H had to come with a spreadsheet. Now, there were plenty of spreadsheets written in Ford, but without the possibility to read key presses or some kind of cursus binding, they were impossible to port to 40H. But then I got an idea. Why not make a completely console-driven version, one that resembled the way my humble line editor worked? Now that was a thing. It took me only a Saturday morning to put it all together. But how does it work? In Ford there's such a thing like a dictionary, a list of strings coupled with execution tokens. Now you ask, what is an execution token? In C and other languages, it is better known as a function pointer, and this simple basic program shows how it works. Here we got a loop and a set of subroutines with line numbers. We can enter a line number and consequently the routine at that line number is called. We even got a subroutine that makes us leave the main loop and exit the program. Now, consider this line number to be an execution token. If we call it, the equivalent subroutine is executed. This is such a dictionary. The words without quotes are execution tokens, and the one with quotes are strings. Of course, because this is interactive, we have to allow the user to type in a set of commands. In Ford, every command, in Ford they're called words, is separated by a space, so parsing the input is dead easy. So we got help. Help is not the same thing as save. So we try the next entry. But it isn't load either. Export, not quite the same thing. But help is a match. So we get the execution token and execute that word. Done. So our next word is clear and it works the same way. Next thing is buy, but I think you got the idea by now. But Ford's interpreter does a bit more. It works by honoring these three simple rules. 1. If it's a word, we execute it. We've seen how that works. But if it's not a word, if it's a number, we throw that number on the stack. And finally, if it's neither, we issue an error message. Now, remember that second rule, the one about the numbers. It's gonna prove to be very important. This is my spreadsheet. It has columns which are indicated by a letter, just like ordinary spreadsheets. The rows are a bit different. They're numbered 0 to 4, because that's the way I feel they should be numbered. And here's the fun part. The letters A through D are actually commands that take the row offset as a parameter and calculate the address of a cell. Let's see how this works. Let's resolve the expression 2D. Yes, rows first. It's Ford, honey. Everything is done in reverse. So, 2 is a number, so it gets thrown on the stack. Now D first throws the number of columns on the stack, which is 4. These are multiplied to get the address of the row, which makes 8. Now D is the fourth column, which translates to 1, 2, 3. That offset is thrown on the stack as well. That number is the offset in the row, and it is added to the address of that row, which makes 11. Note that cells in the spreadsheets are numbered 1, 2, 3, etc. And 11 is the address of the 12th cell in the sheet. Now we got the address, we got to assign a value to that cell. And that's done by the equals command. The equals command parses whatever comes after it, white space and all. In this case, it is the string 45, and that is what this cell is assigned to. That's how we enter our values and formulas. Now comes the question, how do we calculate our spreadsheet? And here it gets really interesting, because for that we have to switch to a second dictionary. This graph was generated by for2dot, a utility program which comes bundled with the 4th compiler. Here you can clearly recognize the main word ticks at the top. It's a shade of red. It contains the command loop which interprets the dictionary. Those dictionary words are in gold. The A, B, C, etc. words resolve the addresses by calling element, which is actually just the spreadsheet data wrapped up in a DOS definition. The word that actually prints the spreadsheet to the screen is called show, and it calls a whole slew of green words, which form the second dictionary. You can clearly recognize the arithmetic operators, and a whole new set of column words which actually evaluate the values and formulas stored there by calling vol. If you're interested, the blue words are internal helper words. They are not exposed to the user. I guess you wonder how this comes together in the real world. So let's see. On the left are the values and the formulas stored in memory. On the right you see what is actually shown on the screen. So let's get this show on the road. 45 is a value. It's thrown on the stack and displayed. Easy. 67 is the same deal. Its value is thrown on the stack and displayed. 0A, 1A plus is different. First the address of 0A is calculated. Then 0A is executed, which results in the value 45. Of course, it is thrown on the stack. Then 1A is executed. This time the value 67 is thrown on the stack. Finally, plus is executed. It takes the two values from the stack, adds them and leaves the value 112 on the stack. That value is taken from the stack and displayed. Done. Of course, this is a small, limited program. The whole thing is less than 200 lines. It's not called Tiny Integer Console Spreadsheet or TICS for nothing, but it offers a framework that can be extended quite easily. Introducing the Tiny Console Spreadsheet. This one is a bit more capable. It supports floating point numbers. It also has twice the columns and twice the rows. You can navigate by using the up, down, left and right commands. And you can export your spreadsheet in a wide variety of different formats. Something the Borland version couldn't. Not even CSV. Sure, it's lacking a host of transcendental functions like exponents or logarithms, square roots or trigonometric functions, but these would be quite trivial to add to the dictionary. And that's the fun of Ford. The simple concepts underlying this language are so powerful that even the most complicated things become trivial by comparison. Like, how do you save and load spreadsheets? Easy. You save them as commands and interpret them when reloading your sheet. Why waste lots of codes on some intricate format when you have a perfectly good interpreter? And now for the final, most important question. With so many deviations from the more familiar spreadsheet programs, can you call these programs spreadsheets? Well, a spreadsheet is defined as an electronic document in which data is arranged in the rows and columns of a grid and can be manipulated and used in calculations. So by that definition, TICS and its big brother TCS are actually producing spreadsheets. No way around that. Question answered. It's been a while and I'm sorry for that. Please subscribe if you liked it and I'll see you next time. I'm Hans Beesmer and this was Back and Forth.